What's going on, everybody? In today's video, we cover how to write bash scripts in Linux, complete guide, part 1, introduction. All the commands from this tutorial are listed in the description below, so you can just copy and paste them. So bash scripting is basically automating the commands you'd normally type one by one into the terminal. Instead of doing the same 10 commands every morning, you put them in a file and run that file. It's one of the most valuable skills you can learn in Linux. So let's start from absolute zero. Every programming tutorial starts with hello world, and we're no different. Let me create a simple script. The first line is the shebang, #bang/bin/bash. This tells the system which interpreter to use. A lot of beginners skip this line and then wonder why their script behaves differently on different systems. Always include it. Then we add our commands, make the file executable with ch-mod, and run it. Variables in bash are straightforward, but there's one gotcha that gets everyone. No spaces around the equals sign. Name equals value works. Namespace equals space value does not. Bash is picky about this. To use a variable, you prefix it with a $sign. Let me show you string variables, command substitution, and how quoting affects things. Scripts get way more useful when they can take input. The read command pauses the script and waits for the user to type something. You can add a prompt message with the -p flag so the user knows what to enter. Let me write a quick interactive script that asks for your name and favorite distro. The other way to get input is through command line arguments. $1 is the first argument, $2 is the second, and so on. $0 is the script name itself. $# gives you the count of arguments. $@ gives you all of them. This is how most real-world scripts work. You pass in what you need when you call the script instead of typing it interactively. Now we're getting into the real stuff. Conditionals let your script make decisions. The syntax is if, then else, phi, that's if backwards to close the block. The test condition goes in square brackets, and here's where people mess up all the time. You need spaces after the opening bracket and before the closing bracket. No spaces means broken script. Let me show you a practical example. Loops are where scripting really starts saving you time. The for loop iterates over a list of items, and the while loop runs as long as a condition is true. Let me show you both. The for loop is great for processing files or lists. The while loop is good for reading files line by line or waiting for something to happen. Let's put everything together into something actually useful. We'll build a system info script that reports host name, IP address, disk usage, memory, uptime, and running services. This is the kind of script you'd run on a server to get a quick health check. Notice how we're combining everything we've learned: variables, command substitution, conditionals, and formatted output. Before we wrap up, some best practices: always start with set-e at the top. This makes your script exit immediately if any command fails instead of silently continuing with garbage data. Use set-u to catch undefined variables and set-o pipefail to catch errors in piped commands. These 3 lines will save you hours of debugging. Also, always quote your variables to handle file names with spaces. This has been part 1. We covered the shebang, variables, input, arguments, conditionals, and loops. In part 2, we'll get into functions, arrays, and more advanced stuff. See you in the next one.